with putting this stuff online. So we left last time talking about end behavior models. All an end behavior model is a simpler function that has the same behavior as x approaches infinity or negative infinity. This x, y equals x, is a right end behavior model for this complicated function. When we looked at the graph, okay, that's the end behavior model because that actual function gets closer and closer to it as you go to the right. If you were to change this now so that we went farther to the right, you're going to have to go higher as well here. Just look at the right side of the thing here. And the top, for that matter. Okay, so that gets closer and closer to that. That's what it is. I mean, obviously, if you started tracing and looking, they're going to be slightly different. But the farther to the right you go, the closer they are. Okay, that's what an end behavior model is. A function that has the same behavior. If you look at it graphically, you see the picture. This course is all about looking at it graphically, looking at it algebraically, and kind of comparing those two because you make some connections for yourself. Back to our little thought bubble down here. This part of it is the same, right? The first part of it, the x plus e to the x. As you go to the right, the x becomes the same as y equals x, right? We got y equals x plus e to the negative x. This part of it is the same as what we're using as an end behavior model. This part of it becomes essentially 1 over infinity times e to the infinity, 1 over infinity. One cookie divided by an infinite number of people. How much of a cookie are you going to get? Pretty much nothing, right? You get an infinitely small piece that just gets divided up amongst, well, it's infinite. Infinity is a hard number to comprehend. It's not a number, right? It's a concept. Take one cookie and divide it by 1 trillion people. You're going to get such a small amount that it's not even possible, right? You'll get one molecule. Now I've distracted you by talking about cookies. Anyways, let's right, using those limit properties and splitting it up, you can look at each part separately. And you notice that one x over x is 1, and the other one's going to be 0. When you involve infinity here, you have to kind of do some thinking like that. If we do the other one's a little bit more difficult. Okay? If you want to show the left end behavior model of this, now I'm going to have to put it down below here. What do we have? We have limit as x approaches negative infinity, right? We're going to the left. And we want f of x over, what is the end behavior model we're using for that? H of x, which was e to the negative x, right? That limit is equal to limit of this. You got to keep writing limit of until you actually evaluate the limit. So we have x plus e to the negative x divided by e to the negative x. Okay, this one's going to be harder because it's got negatives, and then it's also going to involve kind of thinking about negative infinity. If we keep going with this and simplify it the same way we simplified before, what do we have here? We have x over e to the negative x plus e to the negative x over e to the negative x. The right side is easy. You should, if you got it split up like that, you should probably put brackets around it. Okay, the second term is the easier term to deal with here. E divided by e to the negative x. I could actually write this as, if I wanted to, dividing by e to the negative x is the same as multiplying by e to the positive x, right? And then this is just going to be 1. Now, we're kind of thinking about a negative infinity here, though. If you want, you could leave it the way it was before, or you can sub it in here. So you could think x over e to the negative x. Remember, we have to do our thinking here. What do you get when you start thinking about what infinity is there? We got negative infinity over e to the... If I go minus negative infinity, I have this, right? That's if you put your negative infinity in there, that's what you get, right? If you put your negative infinity in here, you get negative infinity times e to the negative infinity. E to the negative infinity is like it's on the bottom here, right? This really makes you change from the straight line mouth to this, right? Actually, it probably makes you change to that, because you don't know what does that mean? Infinity divided by e to the infinity? You can't really... It would be tempting to say e to the infinity is like infinity and negative infinity is negative 1, but it doesn't work that way. This example is actually slightly beyond what we're going to do in this course, and I mean this is slightly beyond. If you look later on at one of the chapters in like chapter 7 or I think it's chapter 8, when you have things like this that are hard to put together in your mind what is actually happening, you'll study that if you take a full year calculus course at a university. It's called an indeterminate form because it's hard to tell what's going on there. Really, if you look at this, this gets bigger faster than this gets bigger. As you put numbers in there, the bottom number gets bigger way faster than the top number. Pick any number you want, right? You could always just look at what's happening as I put numbers in there. Instead of saying infinity over e to the infinity and I don't know what it is, just look at what happens on the calculator. As you put in x divided by e to the x, and you put in 100, e to the 100 is going to be a huge number. The bigger you make the number, this is actually going to approach 0. If you look at that part separately. Even though you're showing this analytically, you can show that this is actually 0 here. Okay? If you look at this part on a graph, now, so you know, as you're letting it approach negative infinity, you got to put in x times e to the negative, x times e to the x, and then start to make the numbers more and more negative. Why don't I actually do it here? Virtual calculator fell asleep. So I'm going to look at deleting that. What did I say I wanted to do? X divided by e to the negative x? And then make x more and more negative, is that right? That's what we have there. We got x divided by e to the negative x, and we're making x more and more negative. Remember what you're doing when you, like, I know we're thinking of this infinity stuff, but you really need to think about whether, you know, what's happening as x gets closer to infinity or negative infinity. Let's start it at 0 and let's go by, well, you could go by 1s first, and then we'll just go upwards in the table here. What's happening to this? What's happening to the value of just that part separately? Yeah, absolutely. This is 0, right? You see there's an exponent there, times 10 to the negative 10th is basically 0. You can check that for yourself, but I mean this is still working through this analytically, showing that it's 1. Since this is equal to 1, since the limit of the ratio is 1, it's an end behavior model. F of x over h of x. Since that's true, then it's an end behavior model. That's what we set up above. Okay? We're okay with that?